You are welcome to DaveTuts Academy, where we are devoted to building excellence in students, especially when it comes to the basics of the STEM subjects. Our video today is going to be our venture into the Cambridge IGCSE exam. We are going to start with the mathematics paper 4, which is the extended paper for the February 2022 058042 mathematics paper. This paper is going to take 2 hours 30 minutes in the exam hall, and we are going to do our utmost best to compile the solution to all this particular question paper for you to build excellence in your academics and to gain that headway that you are looking for. I am an advocate for the fact that you only get to be better by getting your hands dirty. So for this particular paper, for this particular video, just get your pencil, get your biro, get your worksheet, get your calculator. Let's work together. It's that to do this, you are going to build the proficiency that will give you that leverage to ace this exam wonderfully. So let's just get that, and then we can forge ahead with this video. Now, I am an advocate for sticking with instructions, and the very first set of it is that you have to write your name and your center number in the spaces that are provided, which I'm also complying with here. Okay, so once you do that, you will be on the way to getting your mark done and dusted. And then we have this instruction set. So looking at the instruction set that we have, you have to answer all of the questions. Use blue or dark blue pen, then use pencil, HB pencil for diagrams, and so on and so forth. But for me, the highlight is particularly here. Okay, these three are actually okay for me. In the first case, show all your working clearly. Don't be ambiguous in any of your working. And then if you are going to be rounding up any number, so you round up to 3 significant figures, or if it is in degrees, you have to round up to 1 decimal place, unless another level of accuracy is specified in the question. So please, students, let's just take note of this. When we are working, we are going to be showing them and applying them as appropriate. And finally, if you are using pile, is that I'll use our calculator value, or we use 3.142. And with that, we should be able to be good and fine to say we want to launch forth into this particular question, noting that the total mark for this paper is 130, and then the mark for each question is shown in the bracket to the question. Now, you need to be quite observant of this, so that sometimes you just get to see some question, then maybe you are stuck, but perhaps it's just 1 mark, then you can just gloss over and go to other questions, so that you don't just get stuck on that particular question set. So with this preparation, I think we are prepared to go ahead and delve into this question. I hope you have gotten your paper, your pencil, your biro, and your calculator, because I want us to do this together. So let's go ahead and solve our questions for this exam paper together. Here in our first question, we are told that a company employed 300 workers when it started and now employs 852 workers. Our mandate is to calculate the percentage increase in the number of workers. For us to solve this, the percentage increase that we are asked to get, we can solve by making use of the change in the number of workers over the original number of workers multiplied by 100%. Okay, and in this case, that change is the difference between the total workers now, which is 152, minus the total workers that started initially, that is 300, over that original number of workers that started multiplied by 100%. Okay, so what we can have here is 852 minus 300. That is going to give us 552 over 300, and then multiplied by 100%. Of course, these zeros we actually cut out, so we are having inherently 552 divided by 3. Then we can use our calculator to say we have 552 divided by 3. What's that going to give us? This is 184. So what we have as our answer is 184%. Okay, so yeah, of the 852 workers, we are looking at this question B. The ratio of part-time workers to full-time workers is 5:7. We have to find the number of full-time workers. So again, what we're having here is that we have a total of 852 workers, but we have a ratio of part-time workers to full-time workers is equal to 5:7. So if the ratio of these two sets is 5:7, we can say the total ratio is actually the sum of that 5 and 7. So that is 5 plus 7, which is 12. Okay, now for us to get the number of full-time workers, so full-time workers is going to be the fraction of the full-time worker, which is 7, because say part-time to full-time is 5:7. So full-time is 7 over the total ratio, which is 12, multiplied by the total number of workers we are talking about multiplied by 852. This is what we need to put into our calculator now to say we have 7/12 multiplied by 852. Okay, so that's 497. So this is 497 as the total number of full-time workers that we have in this company. All right. Now, for this question, we are told that the company makes 40,600 headphones in 1 year. We have to write this number in words. Okay, that's quite interesting. We just need to write 40,600 in the space provided, and I think that's a bonus mark. Okay, then we have to write this in standard form. So we have 40,600. Now, for us to write in standard form, we are going to move the decimal place. So it's as if we have this as 0.0, but then we're going to move the decimal place backward, and that will be 1, 2, 3, 4. So only 4 will be remaining, and we'll move it back 4 times. So we can say times 10 raised to power 4. So if we want to write it out in this form, we can say this is 4.06 times 10 raised to power 4 as the standard form of this particular value that we're given, 40,600. Yeah, for this question, we're told that in 1 month, the company sells 3,000 headphones, and of these, 48% are exported, 3/8 are sold to shops, and the rest are sold online. We have to calculate the number of headphones that are sold online. Okay, let's see if we can get a pictorial view of what we are talking about here, if it's going to help us get what we are expected to get in this particular case. Okay, so we are saying that we are looking at this total number of headphones. Initially, we are told that first 48%, so 48 should be somewhere here. So we have this as 48%. They are exported. Then 3/8. So we have the whole can be 8. So 3 division there. Maybe we are looking at something like this. So this is 3/8 are sold to shops. So this is export. This is shops. Then the rest are sold online. So this is the online sales. I can call that X. All right. We have to calculate the number of headphones that are sold online. So this whole is actually nothing but what? 3,000 headphones. Okay. Very good and very fine. So for us to get the number of headphones that are sold online, let's take this as a whole fraction, that this whole is just synonymous to, let's say, a 1 as a whole entity. But now for us to get X, we can see that 48%, let me peg it like this. We see that 48%, which is 48/100, plus 3/8 plus X, all of these, they add up to the unitary value of this sales, which I'm taking as 1. Okay, that one is actually 3,000. All right, so if that is the case, I can get an expression for X to say that my X in this particular case is going to be 1 minus the sum of 48/100 plus 3/8. Okay, so I can peg this as 1 minus 48/100. Maybe that would be 4 can go in both. That would be 12/25 plus, okay, when I'm opening the bracket, this will become minus 3/8. So X itself, I can take as a fraction in which to find this LCM, I can say I'm using 200. I can say it's just 200 minus 25 in 200 is 8. 8 times 12, that will be 96. Then minus 8 in 200 is 25. 25 times 3, that is 75. So this is what I need to punch into my calculator, that 200 minus 96 minus 75 is equal to 29. So this is 29/200 is a fraction that is equivalent to online sales. So that online sales is going to be 29/200 multiplied by the total sales we are talking about, which is 3,000. So we can just cut these two so that we have 29 times 30/2. So I'm having 29 times 30 divided by 2. What's that going to give me? That's 435. So 435 is what we are having as the number of headphones that are sold online And I would do well to just write that here, that 435 is what is going to be the number of headphones that are sold online. So here we are being told that 1 year the sales increased by 15%, the following year the sales increased by 18%. We have to calculate the overall percentage increase in sales. So if we said the original sales, if we peg that as, let's say, is Y. So in the first year, the 15% increment will amount to the fact that what we're having is, originally it is 100%. With the 15%, we need to add 15 to it over 100 of x. So this is nothing but 115 over 100 of x, which is nothing but 1.15x after the first year. Okay. Now, in the next year, we are having another 18% increment. So this is quite interesting now. The other 18% increment will mean that just like we do here, that means we're having 118 over 100, but that is going to be the increment on 1.15x. So we have it on 1.15x. All right. So if we want to do this, we can make use of our calculator to say 118 times 1.15 divided by 100. That's equal to what? 1357. Okay, that is 1.357x. And now we want to reverse engineer. That means we are saying that the percentage increment is actually equal to 1.357, means we are saying 100 plus 35.7 percentage increase in x. So it's as if we are having 100 over 100, which is the unity, plus 35.7 over 100 of x. So with this, we know that, of course, this is the whole entity. So the additional is the 35.7 over 100 of x, so that that increase that we are looking for is nothing but 35.7% increase. I hope this is quite simplified enough for you to understand, students, that is just that increment. Look at it, say overall percentage increase. Okay, so that increase is just going to be the multiplication of that 15% by 18%, but scaling it over 100, that will be 35.7, and this question would have been dusted and answered as requested. We had this question on graph in which we are told that the table shows some values for equation y is equal to x squared minus 1 over 3x defined in such a way that x is not equal to 0, because if x is 0, this will be undefined because we have 1 over 0. Okay, so x is not 0 at all. Then the y values are rounded to 1 decimal place. Okay, so from the instruction set that we had before, we are told that we can round up to 3 decimal places or 1 decimal place for degrees, but here we are being specifically told that we are to round up to 1 decimal place. So we just stick with this and not with what the instruction was saying initially. Our first mandate is to complete this particular table that we have been given. Now, this is what I love to do. I will just say I want to start fresh. This equation, y is x squared minus 1 over 3x. I will just say I want to do that. Alpha, which is written in egg, and close brackets, you can see we have x that is also written in red. If I press that, it will give me that x. So I can raise it to the power of 2 minus, now I have a fraction. 1 is the numerator and 3x, 3, again I want to write x, which is alpha, close bracket, is that 3x. So this is how I would normally generate my table in this particular kind of case. So I can just say that for me to get the value, I can only calc. So it's prompting me asking for the value of x. Let me start with minus 1 that we have has been done already. So I have x is minus 1. What's that going to give me? So this is 4 over 3, and if I put it in decimal place, this is interesting. This is 1.3333 because that bar on top of 3 shows that is a repeated value. So it's 1.333. But like they said initially, it said it had been rounded to 1 decimal place, so they only wrote 1.3. Now, since I can see that my calculator is giving me the right value, I can now solve for this. That let's calc from when x is minus 0.75. What's that going to give me? I want to write it in decimal. Okay, this is 1.0069444444. But again, we are looking for 1 decimal place, so that would just be 1.0. Then, for the case in which x is minus 0.5, I want to calc to say minus 0.5 is the value for x, and we are press equal to, this is the value in decimal place. Okay, this will now be rounded up to 0.9 in one decimal place. So we have 1.0 and 0.9. So I can say here I have 1.0, and here I can say I have 0.9 as the values for y for the values of x that were given in the table. Okay, so now on the grid we have to draw the graph of y is equal to s squared minus 1 over 3s for minus 2 to minus 0.1, and the one for positive values of x has been drawn already. So if we look at that particular graph, okay, we are seeing that the one for positive values of x, the one to this right hand side, has been drawn already. We have to take the ones for this left hand side, and we're going to be using the table that we got there to actually compute our value. So let's look at this holistically and see how we can solve it. So we're going to be extrapolating these values. In the first case, when x is minus 2, you can see this is minus 2 here, okay, y is 4.2. Now this is quite interesting. For this particular vertical axis, for example, from 3 to 4, we have 10 boxes, and of course we have from 3 to 4. So that means each one is taking 0.1 as the value. So in that case, we have 3.1, 3.2, 3.3, 3.4, 3.5 as the middle, 3.6, 3.7, 3.8, 3.9, and 4.0. So the 0.1 that is the division in this particular case. So when we're looking at 4.2, so this is 4, we have 4.1, this is 4.2. Our mandate now is to get the point of intersection when we move 4.2 to meet up with 2.0, just like this. And our interest is the point of intersection. So this is how we're going to be doing all the other ones. But students, you can practice with this. I'm not going to be drawing the lines again. I'm just going to locate the point of intersections, and that will be good and fine. Okay, so let me just say what I want to input here is here. That's going to be x is minus 2 and y is 4.2. In the second case, x is minus 1.5. So this is 1 minus 1, this is minus 2. In between them will be minus 1.5. I have that, and then y is 2.5. 2.5 will be directly between 2 and 3. So here that will be 2.5. Okay, so I can say I'm looking at here as a point of intersection of the two. When x is minus 1, y is 1.3. I believe you can get it now. Minus 1 for x and 1.3 for y. That is going to be here. Okay, and then x is minus 0.75. So this is minus 1, this is 0, this is 0.5. So in between them here, this will be 0.75. And then I want to juxtapose that with 1.0. This is going to be that value there. And then 0.5, which I identified as here before. And 0.9 will be here. Okay. Then minus 0.25 will be between 0 and 0.5 here. And then 1.4 should be here. So I'm looking for the cross section of the two together. I'm having something here. Okay. And then minus 0.1, that will just be for x. Minus 0.1 will be 2 boxes here. And then 3.3 will be here. So the intersection of the two, we are having something here. So those are the lines, and I think since we are done with the table, I can just scroll down so that I can look at my graph holistically. Okay, so all that is left is for me to just join all of these points together with a French curve, and that will give me the graph that we are requested to draw. Okay, so I'll just be doing that right now. So just to make sure that this is showing, I will use blue write-up. Okay, students, just use your pencil and you should have something like this as that particular graph that we're expected to construct. Okay, and like we're stipulating that for this particular graph, x is not equal to 0. You can see here we're just moving towards 0 for the x-axis. There's no value for y when x is 0. It is undefined. That's why you can see the y is just moving on. Here on the positive side is going down, on the negative side is going up, and then we don't have values for y. So that is consistent with what is expected for us. So here we are told that by drawing a suitable line on the grid, we are to solve the equation x squared minus 1 over 3x plus y is 0. We need to recall that the value of y itself is x squared minus 1 over 3x. So this equation, what we are having here is that we can see that this whole is y. So if we want to put it as y, we can say y plus 1 is equal to 0, such that we have that y is actually minus 1. We subtract 1 from both sides. Now, for us to solve this by drawing a suitable line on the grid, that means y is a constant that is defined as minus 1. It's not dependent on x at all. That's why the variable x is not featuring here. And that means that we need to look for the point where minus 1 is on y. So this is minus 1. I'll just draw a straight line across that to define this particular equation. And we want to do that, we can just draw that straight line to say it's nothing but this. And then as a rule of thumb, students, we need to always ensure that we label our graph. So here, I would just like to write that this is x squared minus 1 over 3x plus 1 is equal to 0. Okay, the other one that have been done, and then we know that this other one, okay, is the one that we have been asked initially. I think we are good and fine with it. So this is what we are expected to use to solve the equation. How do we solve the equation? That means we are being requested to look at the point of intersection of this line y is equal to minus 1 with the curve that we have initially. We can see that here I want to use red ink there just for the sake of explanation. Here we can see that that is a point of intersection, and for us to get that, we can just trace it up to the x-axis to say we are looking at something like this. Okay, so this value here, that is going to be the solution that we are being requested to find. And if you have to observe it, now we are saying that in this particular case, since this is 0, this is 1, here this middle will be 0.5. Okay, so what I mean is this is 0.1, this is 0.2, this is 0.3, a little bit to the right hand side of 0.3, this is 0.4. So we can say this is nothing but like 0.3. Okay, so that's what we are going to actually feature as a solution here. That is like is 0.3, right? So there, that is 0.3. But now, as a rule of thumb, I can also use my calculator to confirm, to say that, look at this, just look at this. What we're having is that, okay, this, let me just add it, plus 1, we're saying is equal to, and for me to get that equal to, is an equality sign. It is this given in red. I will press alpha calc. You can say is equal to 0. So instead of pressing calc now, I want to solve for this particular equation. I want to say shift calc, which is solve, written in gray. So it wants to solve for x, starting its iteration value from minus 0.5. No, I want it to start its iteration value from 0. So I can press equal to what? Wow. And you can see it's telling me that the solution to this is x is equal to 0.304. And like I was observing on the graph, is actually a bit to the right hand side of the graph. So we are quite on track to say the solution is 0.3. So I can come back to my worksheet to say from the linear graph, the solution is at x is equal to 0.3. So here x is nothing but 0.3, which was obtained from this graph, and I'm able to actually reflect it appropriately here as shown in red. Here we'll be working with functions, and we are first asked to find g of f of 3, given that f of x is 1 plus 4x, and then g of x is x squared. Here in this particular case, we have to find g of f of 3. First, we should find the f of 3, and for us to do that, we just say f of 3, and here we can see that f of x is defined as 1 plus 4x. So we can say we are replacing x with 3 here, so we have 1 plus 4 times 3, which is going to be 1 plus, first, we evaluate the one that is multiplication from BODMAS or PEMDAS. So that will be 1 plus 12, which is equal to 13. So g of f of 3 will inherently mean we are looking at g of 13. And what is g? The operation g is actually the square of the variable we are talking about. So this will be 13 raised to the power 2, and that is 169. So the answer here is 169, right? In the second case, f of g of x. So first we need to carry out g of x. So what's g of x that have been defined initially as s squared? So f of g of x will mean that we are carrying out f on s squared, and that means that wherever we find x, we're now going to put s squared in that case. So this will be 1 plus 4 multiplied by, instead of x, we have s squared, and this is the best we can do with this. So our final answer is 1 plus 4s squared. Okay, and then in this other question, we are looking at the inverse function of the function of x. So in this particular case, it's as if you recall your indices, maybe you're having x raised to the power minus 1 multiplied by x, or okay, don't let me use x, let me say I want to use a. You have a raised to the power minus 1 multiplied by a. You know, this is just as if you are having 1 over a multiplied by a, which is 1. Implying that if you are finding the inverse of a function on the function, you are actually annulling that function itself. Whatever operation you are trying to carry out, you are annulling. So this is going to be nothing but x. Okay, or maybe I can look at the example on matrices in which you have the inverse of a matrix multiplied by the same matrix is going to be an identity element. So eventually you're just going to see that the inverse of the function of a function of x is nothing but x. So here x is still going to be the answer. They're just trying to test your understanding of the concept of inverse of functions and co. Now in this case, we have to find the value of x when f of x is 15, and recall that we are giving that originally f of x, we are told that it is 1 plus 4x. Now we are told that that f of x is nothing but 15. So now we have to find the value of x. This implies that what we're having is 1 plus 4x is equal to 15, so that 4x will be 15 minus 1 if we subtract 1 from both sides. So 4x is equal to 14, and to solve this we can divide both sides by 4, and then we can see that on the left hand side 4 will cut, such that we are having x is 14 over 4, which will be 7 over 2, or in decimal place x will be 3.5, and that is as good as this question gets. So, okay, for this question we're told that in this triangle ABC, AB is 45, AC is 29.5, and BC is 35.3. Then angle CAB is 51.6 degrees. We have to calculate angle ABC. First, let's identify this angle ABC. This is ABC. So inherently, this angle here, that is what we are requested to find. This is the angle that we are looking for in this particular question. And how do we find this angle? We can see that for this particular triangle, we know all the sides. We know one of the angles. We are looking for this other angle. I think the sine rule will be ideal for us here, because we can relate the sine of the angle over the side opposite it to one another as a constant ratio. So in this particular case, since I have A and the side facing it, and I'm looking for B, though I have the side facing it, then I can say sine of the angle of A over the side facing A, which will be small a, is equal to the sine of the angle of B, which is ABC that we are looking for, over the side facing that angle over B. So here, if I want to use this, that means I can say, what is sine A? That is sine 51.6 over A, the side facing it. This is 35.3 over 35.3 is equal to sine B, which we are looking for, divided by the side facing it, which is B, 29.5. So in this particular case, all I just need to do is cross multiply, such that I'm going to have sine B is equal to 29.5 sine 51.6 divided by 35.3. You can see how I'm taking time to just explain all my steps, and in this case I will have sine B to be, let me use my calculator now, 29.5 sine 51.6. okay, divided by 35.3. What's that going to give us? 0.6549. 6549. And then with this, I can get B to be the arc sine of that value, 0.6549. So I can still bring my calculator to say arc sine, the answer that I just got, was that going to give us 40.914. But recall, in the instruction set, we are told that when we are working with decimal, we round up to one decimal place. So here, my answer is going to be 40.9. So B is nothing but 40.9 degrees. So I can just state that out, that the answer is 40.9 degrees. That is angle ABC. Okay. Here we have to find the area of triangle ABC. Let's look at the parameters that we have and the formula that we can make use of. Okay. The area ABC. Okay. Since from what we have, okay, we also got this as 40.9 degrees. Okay. Now we say we want to use half multiplied by the product of the sides and the angle between them. Here we have this side, we have this side, and we have the angle between them. So we can say we want to use half. This is B because it's facing this apex B, and then this is C because it's facing this apex C. I can say half BC sine A. So that means formula I want to use is half BC sine A as the area of this triangle, and B is 29.5, C is 45, A is 51.6. I think that would be good for us. Okay, so I can say the area of this triangle is equal to half BC sine A, and okay, let me just call it area. So that area is going to be 1/2. B, just like we have identified now, is 29.5 centimeters. Then C is 45 centimeters. Then sine A will be sine 51.6. I love to actually make use of the values that are given in the question already, so that I will not be having problems with approximation, or if I had missed the previous question, I will not use that wrong value to actually get the subsequent values. But here, I'm using raw data that we have been given, so the margin for error will be drastically reduced. So I can just say I want to say 1/2 is 0.5 multiplied by 29.5, not 295, 29.5 multiplied by 45, then sine 51.6. Okay, so this is 520.176. Now recall that if you are working with normal operations, we are asked to round up to 3 decimal places. So this will be 520.175. I will round up to 1 and add to the previous number. So I have 520.177. So this is 520.177 centimeters. But since in our instruction set we have been told that we should round up to 3 significant figures, then we can say this is nothing but 520 centimeters square. So our final answer will have to be 520 centimeters square. We have here another question on triangles and co, in which we are told that this diagram shows a quadrilateral PQRS that is formed from two triangles PQS, this one here, and then triangle QRS. Okay, now triangle PQS is isosceles. That is good. That means this side and this side, they are equal, and you can see 32 centimeters and 32 centimeters. Okay, then PQ, PS, they are equal, 32, and then guess PQ is 56 as given, then QR is 47, QR here is 47, and then guess QR is 60. Okay, first we have to find SR. So where is XR? This is SR. Okay, so if I'm to look at that SR, okay, since it's facing this Q, let me just call it Q. All right, how can we get this particular Q? Okay, if we can get the value of SQ here, this SQ, since it's facing R, let me call it R. If I can get R, I can make use of the cosine rule to say that for this particular question, Q square is going to be, okay, since 47 is the one facing S, I can call this S. Q square is going to be R square plus S square minus 2RS cos the angle Q. This angle 60 that is facing Q. So that is the guide to the cosine rule, and this is the cosine rule that can inherently help to solve this question. Now, this is just the method I want to choose. You can look at some other means. Maybe you can try your hands on that so that you can get to master proficiency in solving questions like this. But I think I can get this side SQ, which I've defined as R, from this diagram, because here this triangle is tagged as isosceles triangle. If I said I would like to just say I want to bisect it, just bisect this triangle into two equal parts. So if I look at this angle here and this angle here, they are going to be equal because they are the base angles of isosceles triangle. So I can see that this angle here and this angle here, they are equal. That is good and fine. But beyond that, since I've called SQ, I'll call it R. Half of it, this R over 2, I can get by making use of SohCahToa, because this line in purple is actually dividing this to a right angle triangle. Since it is isosceles and I'm bisecting it into two, this will make it a right angle triangle. And so I can use SohCahToa to say for the triangle PS to this point, okay, that's the right angle triangle in which I know this longest side, the hypotenuse. This will now be 28 degrees, which is half of 56. So I'm looking for the opposite to 28, R over 2, and then I have the hypotenuse. So I can say from SohCahToa, it's telling me that the one relating opposite to hypotenuse is sine. So it's telling me that sine 28 is equal to the opposite to that, the side facing it, this side which is facing it, is R over 2 is equal to R over 2 over the hypotenuse, which is 32. So I can solve for R over 2 here to say R over 2 is equal to 32 sine 28. And what's that going to give me? 32 sine 28. This is 15.023. So this is 15.023. Then I can find my R from here. R will be 15.023 times 2. Okay? So I can just inherently just write that out. So having this now, I can go ahead to try and solve for SR, this SR, which is Q, to say that with all the parameters that I have, I can say Q square is equal to, what's the value for R? That is 30.046 raised to power 2 plus S square, that is 47 raised to power 2 minus 2 times RS, 2 times 30.046 multiplied by S, that is 47, then multiplied by the cosine of angle Q, which is 60, cos 60. Okay, that cos 60 will be half. So we can just say we want to make use of our calculator that, okay, 15 raised to power 2, we have it as 30.046 raised to power 2 plus 47 raised to power 2 minus 2 multiplied by 30.046 multiplied by 47, then cos 60. Okay, I think you can check to ensure that you got all the parameters right, and you can press equal to. So this is 1699.600. So this is Q square is equal to 1699.600, such that Q itself is equal to square root of 1699.600. Okay. So we will take our calculator, the square root of the answer that we just got, that is 41.226, 41.226 centimeters. From here, we should round it up to 3 significant figures. So that will be 41.2 centimeters, because 2 is now up to 5. So we'll round it down to 0 and that to the previous number, so that SR, which is Q, okay, we can append as 41.2 centimeters, and that will be our final answer in this particular case. So moving on with the question, our next mandate is to calculate the shortest distance from P to SQ. And if you are to look at the diagram, that shortest distance from P, this is P, to SQ, this line, you can see that it is the line drawn in purple, in which we have this as 32 centimeters. We have this angle 28 degrees. We have R over 2, which we have gotten as 15.023. But do we really need that? Let's just look at this triangle and see how we can solve it effectively in this question. Okay, so if you are to look at that extrapolated image, this is what we are having, and that's what we are looking at, in which we are looking for x, that is distance pt, the distance from the P to the line SQ. Okay, so it is pt, which is denoted as x here. And we are to make use of SohCahToa. We can see that looking at angle 28 degrees, the hypotenuse in this case is 32, and the value we are looking for is distance between P to this T, which is x, that is the adjacent. Okay, the adjacent is x, which is what we are looking for. So what is relating the hypotenuse and the adjacent? We can see that it is cos. So here we can say cos 28 is the adjacent, which is x, over the hypotenuse, which is 32, such that x will be 32 cos 28, and we can just try to find out from the calculator. So we have 32 cos 28, and what's that going to give us? 28.254. So this is 28.254 centimeters. But again, we have to get this to 3 significant figures. 5 will round up to 1 and add to 2, so that will make it 28.3, such that our final answer will be 28.3 centimeters as the shortest distance between P and SQ. So that is that for this wonderful question on the figure that we are given here, making use of the cosine rule and SohCahToa to solve as appropriate. All right.
Here in this question, we're told that the table shows information about the mass in grams of each of 120 letters. So we have this mass in grams, and the frequency, that's the number of times they're actually occurring. So first we have to calculate an estimate of the mean mass. Now to get an estimate of the mean mass, and I love that they're telling us that it's an estimate. Okay, so you can see it is going to be giving us x bar is equal to sigma fx, which is summation of the product of the frequency and the data entry over summation f, the total of the frequencies. Okay, so in this particular case, I think why they are telling us the estimate is that ideally 0 less than m less than or equal to 50 will mean that we are taking a data entry from say 1 to 50, and if you are looking at this and you want to find the median, that would have been 25.5, but that would be quite equivalent to be putting in 5.5. So I think that's why they are talking about the estimate. So in that particular case, we can just take 25 as the midpoint of this data value. So in the first case, this will be 25. Here it will be 75. In this third case, 100 to 200, that will be 150, and then 200 to 500, that will be 350. So that is something we need to know, that these are not linear. Okay, it's not the same width that we are having in each of these data entries. So for the first one, you can say the product of the frequency and the data entry will give us 25 multiplied by 43. In the second case, we are going to have 75 multiplied by 31. In the third case, we are going to have 150 multiplied by 25. And finally, in the last case, we are going to have 350 multiplied by 21. Okay, so all of this, we are saying we are dividing by the sum of the frequency. So we have here 43 plus 31 plus 25, and then finally we're adding 21. So this is what we need so that we can get our answer holistically, and we can bring in a calculator to evaluate this. Okay, we say in the first case 25 times 43, our calculator will use PEMDAS or BODMAS by itself, so we can just put in these values straight. It will take care of the order for us, plus 75 times 31 We just need to ensure we don't make mistake in inputting the values. Plus 150 times 25, then plus 350 times 21. So what's that going to give us? 14500. So this is going to be 14500 divided by the sum of all these frequencies, 43 plus 31 plus 25 and plus 21. Okay, so this is 120. So that our estimate of the mean will be 14500 divided by 120. Okay, so this is 120.83333. So you can just say this is 120.833. We can put that as our answer as 120.8 grams. Okay, Iraj draws a histogram to show this information that we have already. Then it makes the height of the first bar to be 17.2 centimeters. We have to calculate the height of each of the remaining bars. So I've come up with a sketch of what that histogram is going to look like. Students, you don't need to actually get this done in an exam. I just want to use this as a means of explaining the concept behind what we are going to be working with here. So in the first case, we are told that it makes the height of the first bar 17.2 centimeters. So for that particular bar, the masses that we have is ranging from 0 to 50 and the frequency is 43. So we have frequency on the vertical axis and the mass on the horizontal axis. So 43 is taking 17.2 centimeters. That inherently means that there is a particular scale that can actually relate 43 to 17.2 when we have a class width of 50. Okay, so I just want to show you that so that we can use that as an information to help us solve this question holistically. Now, in the second case, for the data set, we have the frequency to be 31. So this is 31, and that is from 50 to 100. And then in the third case, now this is where it gets interesting. 100 to 200 will be two divisions of 50. So we have 100 here. This will be 150, and then next that will be 200. So that is taking a frequency of 25. And in the same way, in the last case, we're having from 200 to 500, taking a frequency of 21. And that's why we have this long division 200, 250, 300, 350, 400, 450, and 500, having a frequency of 200. And then we need to get the height of each of the remaining bars that we are going to be doing and working with it. So if we are going to be doing that, there is a formula that is generally used that the frequency density in histogram, the frequency density is given as the frequency divided by the class size. This particular formula is what is going to help us to solve this question holistically. And if we'll be making use of it, we are going to look at that particular first case in which already we have been given what is being used. So we can say the frequency density is going to be, for this case, we have 43 as the frequency. Okay, then the class size is from 0 to 50. So we can say this is 50 minus 0. Then we are multiplying it by a factor that is helping us to get that bar as 17.2 centimeters. That factor is a scaling on the graph sheet that Iraj used to draw that. Okay, so we can say this is the frequency density, and we have been given as what? 17.2. So from here we can solve for x to say that therefore our x is going to be, this is just for 3 over 50, that will be 17.2 times 50, and we are dividing by 43. So this is the multiplying factor that we are using in this case to get the height of each of the bars. So we want to do that, we can say 17.2 times 50 divided by 43. What's that going to give us? Good. So x is actually 20, and then if s is 20, what we need to do to get the height of each of the remaining bars is to use this same formula for the frequency density, but now we use s as extrapolated value to factor in the height of each of the bars. So in the first case, for 50 less than m less than or equal to 100, we are going to have the frequency density to be, what is our frequency? In this case, it is 31. What is our class size? That is now 100 minus 50. 100 minus 50 multiplied by the scale factor of 20. If we want to use our calculator, we can say this is 31 divided by 100 minus 50 is 50, then multiply by 20. So what is going to give us? This is 12.4. So this is going to be 12.4 centimeters. Okay, for 100 less than m less than or equal to 200, we need to note that now the class size is going to change. Our frequency density will be, what is the frequency for that case? It is 25. So we have 25 over 200 minus 100, then multiply by 20. Okay, so if you want to get that again, we can use our calculator. We have 25 divided by 200 minus 100 is 100. Then we're multiplying by that 20, and that's going to give us 5. Okay, so this is 5 centimeters. And in the third case, we're having for 200 less than m less than or equal to 500. What is going to be our frequency density is the frequency, in this case is 21, divided by the class size 500 minus 200, that is 300. Then we are multiplying by that multiplying factor, which is 20. So again, we have it 21 divided by 300 times 20. What is that going to give us? This is 7 over 5, which is 1.4. So this is 1.4 centimeters. So students, I hope you are able to pick a very good understanding of this. And with what we have been given, we have enough data to now say that the height of the bar for 50 to 100, that is obtained as 12.4 centimeters. For 100 to 200, that is obtained as 5 centimeters. And for 200 to 500, that is obtained as 1.4 centimeters. I took my time to actually get this pictorial view so that you will understand it, and I hope it is clarified in this case now. Okay, so moving on now, we are to complete the cumulative frequency table as given here. Okay, so we have those frequencies, but now we are looking at the cumulative frequency, meaning that we need to add cumulatively each of the frequency for the data set. In the first case, we are given the frequency as 43, so this is 43. In the second case, it will have to be 43 plus the frequency of that second class, and that frequency is 31. So we have 43 plus 31, that will be 74. In the third case, we need to add 74 to the frequency of this third data set. So that will be 74 plus 25, and that is going to give us 99. And then in the last case, we are going to still add 99 to the frequency of that last data set. That will be 99 plus 21 as a frequency in this last case, and that will be like 100 plus 20, that will be 120. So this is our cumulative frequency table, and then we can see what we are going to still work with. I think in the next question we are being asked to draw the cumulative frequency table, and then what we just need to note here is that since we are given m is less than or equal to 50, we have our upper class boundary defined already in this particular case. Okay, it's defined, so we can take 50 as our upper class boundary, 100, 200 and 500 as the upper class boundary that we'll be working with, and then we have this as our cumulative frequency. So we want to make a simple guide of what we have 50 and 43, we have 100 and 74, we have 299, then we have 500 and 120. So this is our table of values that we're going to be making use of. In the first case, this is m, and the second case, this is f. In short, this is cumulative frequency, not just f. So this is what we are using, and I'll take that to help us get the construction of the cumulative frequency curve. So here it is. We are being asked to draw a cumulative frequency diagram. I'm giving the graph sheet already, in which we have the horizontal and the vertical axis. On the vertical axis, we have the cumulative frequency. On the horizontal axis, we have the mass. And here, just like I captured those data entry, this is going to be what we are using. We have the masses and we have the cumulative frequency. So we are going to be extrapolating these values together on the graph sheet and then plotting the curve that will join all of the data entries as appropriate. So that's what we are going to be doing right about now. So we are trying to look at the scale that we have here and the values that we are going to be inputting. From 0 to 20, 0 to 20, we have like 10 box division. So these are 10 boxes, and then that means that each box is going to have a value of 2 units. So we have 2, 4, 6, 8, 10. And you can see that is half, so that this is 12, 14, 16, 18, and 20. So it is two values that we have for each of the small boxes. Okay, and then on this horizontal axis we have 0 to 100. I can do this like this. That means this is half, which is 50. Then each one we have to take 10 units. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So once that is clarified, we will know how to get our data extrapolated together. But this is the very first step. We can just do this mentally, and then we'll try and see how to solve the question as appropriate. So having that in mind, we can now say when m is 50, m is giving us 50 at its value. So where is m? 50 is here. Okay, and then the cumulative frequency is 43. We can just have something like this. This is 50 from the mass, and then 43 on the cumulative frequency graph will be 40, 42, 44. So 43 will be in between 42 and 44. So we have something that is like this. Okay, and we are looking at the point of intersection of the two. So this is what we are supposed to just trace for each of the data entry. I'm showing this as a guide so that subsequently you can just know that, okay, this is what DaveTuts is doing, and I can replicate that from my end. I'm only going to indicate the point of intersection. So I can say here I'm having 50 and 43. So that is somewhere here. Okay. And then in the second case, I'm having 74 and 100, or I'm having 100 and 74. So this is 100, very clear on the horizontal axis. Then 74 on the cumulative frequency. 60 is here. This will be 70, 72, 74. Okay, so this is going to be their point of intersection, and I can just note that straight, that here, that's what I'm having there. And then in the third case, the mass is 200 and the cumulative frequency is 99. So this is 200. I hope you can get it straight now. 99 will just be between 98 and 100. So we're having something like this. Okay, just in between. Then we have 500 and 120. So this is 500 and 120. This is the easiest of them all. So these are the points that we have. Our mandate will now be to join all of them together with a curve as appropriate. So we get to put in our French curve. We are going to have something like this as the curve that is joining all of these together. Okay, so that's how the graph is going to look like. Then we have this set of questions that we can look at holistically to solve, and let me just capture it so that I'll be able to just move on my graph sheet to solve them. In the first case, we are looking at the median. We have to evaluate the median. We have to get the upper quartile, that will be Q3. We have to get the 48th percentile, and then the number of letters with a mass m, where 250 is less than m less than or equal to. So we are looking for frequency for the case in which we have 250 to be less than m to be less than or equal to 400. So this is our guide. We can now go to our graph to try and solve this as appropriate. Now I want to just use red ink. Students in the exam, use your pencil on the graph sheet, but just for the sake of explanation here, let's try and see how we can make this pop out so that you can see for better understanding. Okay, so in the first case, to find the median, we are having a total cumulative frequency of 120. The median will be half of that, so we are looking at 60, and then we need to just look at the extrapolation of that particular 60 on the cumulative frequency and get the value of the mass. Okay, so we can just go to 60 here and say we want to trace to the graph. You can see, and then we want to come down to see what that value is. So from the scale that I actually explained the other time, we can see that here half of this is 50, 60, and this is 70. So the median will have to be 70 grams. Okay, so what I did initially was to say for the median, we are looking at half of the total cumulative frequency, which is 120. That is on the 60th position, and that value is corresponding to 70 grams as given from the graph. Okay, now for the other one, the upper quartile is actually the 3/4 position of 120. So here, if you have to cut 4 here 1, 4 in 120, that is 30. So we are looking at the 98th position on our cumulative frequency. We want to see what that value will correspond to. So we can say we are looking at the 90th position will be between 80 and 100. So we are looking at something like here. This is in between 80 and 100. So we can draw our straight line again to meet the curve. And then from there, we can also go straight down to see what that is going to amount to. If we are actually on point, we are going to see that, again, this is 100, 200. In between them is 150. We're having it just a bit to the right of 150. So maybe we can say 151. So this is like 150. Let me just say 153 grams. So that's going to be the upper quartile. And then we also asked to evaluate the 40th percentile. Okay, so 40th percentile, we warrant that we are looking at 40 over 100 of, again, 120. Okay, so we can have this cut out, the zeros, and then that means we are here looking at 4 times 12. That is the 48th position. And again, we go to the graph. This is 40. We have 42, 44, 46, 48. That is what we are going to be using. Okay, so if we want to get that, we'll also trace from that particular point to the curve. Okay, and then we bring the same down. So initially we are having this as something like 153. Here we're having it as, this is like 50. Again, let me just say this is like 53. It's not directly on that line. You can just get to look at this from your question too. Okay, from your graph that you are constructing. For me, this is looking like 53. So I can say 53 grams. Okay, and then finally we have to look at the number of letters whose mass m lies between 250 and 400. In this particular case, we have to have some reverse engineering. So we are looking at 250, which is here, and then we are looking at 400, which is here. We want to get the frequency that corresponds to those class range. We are looking at something like this, from 250 to the curve, and then also from 400 to the curve. We want to get the corresponding frequency range. Okay, I think we are quite on point here. So we are looking at this region that is covering that range of value which we trace coming from 250 to 400, just this region. So we have the masses already. We're only looking for the frequency that corresponds to that. And you can see here, if this is 100, this is 102, 104, this is 106. So we have the lower as 106. We have the upper as just before 120, and that is 118. So for the frequency corresponding to 250 less than m less than or equal to 400, we are having this to be the difference between 106 and 118. So that will be 118 minus 106, and 118 minus 106, that is going to give us 12. Okay, so these are the set of answers, solutions to what we are being asked. In the first case, we are looking for the median, and I've gotten that to be 70 grams. Then we're also looking at the upper quartile, that we got to be 153 grams. Okay, and then we are looking at the 40th percentile, that we got to be 53 grams. And then finally, we are looking at the number of letters with a mass m, where m is between 250 and 400, and we got that to be nothing but 12. So this is actually the solution to this as extrapolated from the cumulative frequency diagram. And if you have been able to do this, then it would have been good and fine. Just know that your exact values may not be what we have here. It can just be an approximation to it, since we're actually looking from the graph and not calculating outrightly. So that will be fine and good for us. Here in this question, we're told that the interior angle of a regular polygon is 156 degrees, and we're to calculate the number of sides of this particular polygon. So the sum of interior angles
of a polygon is generally given by the formula 180 multiplied by n minus 2, where n is the number of sides. But of course, we also know that this same formula is equal to the value of the interior angle multiplied by that number of sides. So what we need to do in this particular case is to equate these two to say that we have 180 into n minus 2 is also equal to 156n, so that if we open up the bracket, we are going to have 180n minus 2 times 180 is 360 is equal to 156n. So if we just rearrange, just subtract 156n from both sides, then add 360 to both sides, we are going to have 180n minus 156n is equal to 360, so that 180 minus 156, let's look at that from the calculator. We have 180 minus 156, that's 24. So we have 24n is equal to 360, and we can divide both sides by 24 so that we can find the value of n by dividing this we cut, and then we have n to be 360 over 24, which we can also look at our calculator. 360 divided by 24, so that is 15. So we can have that our n is nothing but 15, and here we will just append that as 15 and we are good and fine. Okay, in this question we are told that ABC lie on a circle. So this is ABC, they lie on this circle which is having its center at O. Then angle OBA is given as 52 degrees. We have to calculate angle ACB. So let's just identify that angle. ACB is here, ACB. Okay, so that is our angle of interest here that we need to calculate in this particular question. And looking at what we have, we can see that this AO and OB, they constitute the radii of the particular circle we are looking at here. So this is from the circumference to the center. This is also from the circumference to the center. So this triangle AOB is an isosceles triangle in which the base angles are equal. So this is also going to be 52 degrees. Okay, I hope that is just clear that this angle here is also 52. And we are saying that because angle OBA is equal to angle OAB, which is 52 degrees, because they are base angles of isosceles triangle. They are the base angles of our isosceles triangle AOB. Okay, so since that is the case, this particular angle, we can get angle AOB, because we know that AOB plus this 52 and this 52, they constitute angles in a triangle. So we can say angle AOB, the angle at the center, plus the 52 angles that we had already, they will actually constitute 180 degrees, because they are the sum of angles of a triangle. And sum of angles of a triangle, they add up to 180 degrees. Okay, so I'm particularly writing out the reason why these are so that you can actually see that is no magic, right? So that means if I call this angle x, if I call this x, I can say that means that x is equal to 180 minus the sum of 52 in two places. So that will be 180 minus 104, which is 180 minus 104, and that will be 76 degrees. So this angle at the center is 76 degrees. But then finally we can see that ACB is angle at the circumference, AOB is angle at the center of the circle. They are both being subtended by this chord AB. And then from the rule of the circle theorems, we can see that angle ACB, which we are looking for, is going to be half of angle AOB, because it is angle subtended at the circumference as compared to angle subtended at the center of the circle. So that is 1 over 2 of x, which is 1 over 2 of 76, and that will be 38 degrees. Okay, and why am I postulating this? Because it is angle subtended at circumference is half angle subtended at center of the circle. So if we can get all of this, that means our angle ACB that we're looking for is nothing but 38 degrees. Since x is 76, then that will be half of that. So angle ACB that we're looking for is nothing but 38 degrees. All right. So yeah, in this question, we're also looking at PQRST, which lie on a circle. So we have PQRST, the line on this circle. WSR is a straight line. WSR, that's a straight line there. And angle WSP, this angle here is 112 degrees. We have to calculate angle PTR. So first, let's identify PTR. So this is P, this is T, this is R. This angle here is the angle of interest in this particular case. So if you are noting that, I can call it, let me call that angle X, okay? So how can we find this angle S? Something I'm noticing is that if we want to start from the data that we are given, we are seeing WSP to be 112. This angle here, if I call it Y, I can say that this angle Y that I just identified plus WSP is actually angle on a straight line. So I can say the angle Y plus WSP, which is 112, they add up to 180 degrees because they are angles on a straight line. Angles on a line, and the sum of angles on a line is 180. So Y will be nothing but 180 minus 112, and that will be 68 degrees. Okay. So moving on from there, we can see that this X that we're looking for and this Y, they are angles in the same segment of this particular circle. So we can say that angle PSR, which got to be Y, is the same as angle PTR, which is what we are looking for, that we tag as X, and the value is nothing but 68 degrees because they are angles in the same segment of this particular circle. So once the angles in the same segment, they are going to be equal, and with that, we've been able to solve this question to say that angle PTR is nothing but 68 degrees. So that is that about this question. So we can try moving on to the next question. Okay, to this other question. Okay, this is quite interesting now. Let's see how we can maximize the screen. We are told that G, K, and M lie on a circle with center O. So this is G, K, and M. They lie on this circle which has its center at O. Then FGH is a tangent to the circle at G. So this is FGH is a tangent just touching the circle at its circumference and then making a right angle with the radius or the diameter of the circle. And MG is parallel to OH. That's why they have this small arrow notching both of them. So we have to show that angle GKM is mathematically similar to triangle. Okay, we have to show that triangle GKM is mathematically similar to triangle OHG. And we have to give a geometrical reason for each of the statements that we are going to be making in this particular case. Okay, that's quite interesting. Let's look at this and let's postulate what we can get. I can readily see that angle OGH, this is going to be a right angle. Okay, and then this is also going to be a right angle. But like we have been asked, we need to state the reason for which we are saying all of this. In the first case, I can say angle OGH is 90 degrees, and then it's because it is the angle in between tangent and the radius of the circle. Okay, and that same angle is also, we can also see the angle KMO. I can also say that angle KMO is also equal to 90 degrees. And why is that? Is because it is the angle that is subtended by diameter at the circumference. By diameter at the circumference of the circle. Okay, once we have that, we are saying that both of them, they are equal. So I can say OGH is equal to KMO, and of course both of them have 90 degrees as their value. Is that all? That is not all. I can see from this particular image that because we have these parallel lines MG, okay, and OH, this angle here and this angle here, they are alternate angles to one another, so they are going to be equal. See, this line KG, or we can say this line KOG, is actually a transversal between these two parallel lines, MG and OH. So this angle and this angle, they are equal. So if I'm to call this, let me say I'm calling this X, I can also say this is X, right? Or better still, let me use theta. So if I'm calling this theta, I can also say this is theta. So from what I'm postulating, I can readily see that angle MGO is also equal to angle GOH, and I'm pegging this as 90 degrees, not 90, and I'm pegging this as theta, and I'm saying these are alternate angles. Okay. If we further look at this diagram, we can see that this remaining angle here, since we have looked at this angle as a right angle and this one as theta, then this angle here will be nothing but 90 minus theta, so that the sum of the three of them will be 180. And the same also applies here, that this angle here will also be 90 minus theta, so that the sum of the three angles, it will also be 180. So I can still include that to say from this diagram that we are looking at, we are also seeing that the third angle is 90 minus theta, 90 minus theta. But I think even with what we have, that is sufficient, because we are now seeing that from this particular diagram and the postulate that we are making, we are having two triangles in which two of their angles, they are equal. And that means we can say we have two angles in triangle KMG and triangle OGH to be equal. Okay, so we can say we have triangle GKM is similar mathematically to triangle OHG. And why? Because we are seeing that there are two, in short, we can say there are three angles that are equal in this particular case. We have the right angle triangle at M and at G. We have angle theta at G and at O. And we have the other angle 90 minus theta at K and at H. You can also pick any side, and once you're able to justify this, then you've been able to prove this as requested, and your full mark is assured. In this question, we're told that two rectangular picture frames are mathematically similar, and then the areas of the frames are 350 centimeters square and 1134 centimeters square. The width of the smaller frame is 17.5 centimeters. We have to calculate the width of the larger frame. So if you want to look at what we have here, this can be a pictorial view for us that can be a guide into what we are looking at. In the first case, we are having the area of the smaller one to be 350 centimeters square, while the area of the larger one is 1134 centimeters square. Okay, now the width of the smaller frame, this is 17.5 centimeters, and then we have to find the width of the larger frame. If we call this X, now we can look at this. Since we are told that they are similar, that means there is a multiplying factor that can be common to both. And ideally, if we want to find the area, we know that area in this case, maybe we call this A, I will call this B. The area for the smaller one will be 17.5 times A, and then the area of the larger one will be X multiplied by B, and the product of these particular two elements, the sides, will be, in the case of the smaller one, that will be 350 centimeters square, and in the case of the larger one, that will be 1134 centimeters square. We can do this because we are told that they are similar. Okay, and now since they are similar, and what we are looking for is ideally focusing on X, but we know that 17.5 and X, if you look at them and take A over B as a constant, that means that you can say 17.5 over X will be amounting to the square root of 350 over 1134. Now we're able to say this because A and B, they are unknowns for us, but we know that we cannot just relate this left hand side in centimeter to this right hand side in centimeter square without squaring it. That is where the matter of the square is coming into play. So here, if we just say we want to cross multiply, and solve the question, we can have the value of x to be 17.5 multiplied by the square root of 1134 over 350. So this is what we need to put as our final answer. So we can bring in our calculator to say we are looking at 17.5 multiplied by the square root of, now we have a fraction, 1134 divided by 350. Okay, so what's that going to give us? This is 3 over 2, which is 31.5. So this is nothing but 31.5 centimeters as the value of x. So it's as a reason of the fact that they are similar that we brought in this relationship, but we cannot just relate the length, which is in centimeter, to the area, which is in centimeter square. We need to bring in the square root, and then that will enable us to solve this question fine and wonderful. Okay, so here we're told that a picture in a smaller frame has length 15 centimeters and width 10.5 centimeters, both correct to the nearest 5 millimeters. So we need to just note this very, very critically, that if we are giving that is to the nearest 5 millimeter, that means what we are having is plus or minus 2.5 millimeters as the bounds for the length and the width that we're having. But look at this, we are giving the length and the width in centimeters. This is in millimeter. Then we should convert to centimeters. That would be 0.25 centimeters. So if you are looking at the area, which is actually the product of the length and the width, for example, 15 centimeters, we have both a lower limit and an upper limit. So that upper limit will be 15 plus 0.25. So we have it as 15.25 centimeters. And then the lower limit will be 15 centimeters minus 0.25 centimeters. That will be 14.75 centimeters. And in the same vein, for the width, which is 10.5 centimeters, the upper limit will be that 10.5 plus 0.25. That will be 10.75 centimeters. And the lower limit will be 10.5 minus 0.25, which will be 10.25 centimeters. So these are the upper and the lower limit for the width, which is 10.5 centimeters. Now that we are being asked to find the upper bound for the area, then that means we are going to multiply the upper bound of the length and the upper bound of the width. So this is what we are looking for. I didn't mean that we are looking for the lower bound of the area, then we could have multiplied these particular lower bounds for the width and the length as appropriate. So since this is what we are looking for, we can say our area, which is the upper bound, is going to be 15.25 multiplied by 10.75. Okay, so we can use our calculator to say we are looking for 15.25 times 10.75. What's that going to give us? 163.9375. Okay, this is 163.94 centimeters square as the upper bound for the area of this particular picture. Okay, so here we are looking at this question too, and we are being told that in a sale, the price of a large frame is reduced by 18%. So look at the word. We are looking at a reduction by 18% in this particular case, okay? And then party pays $166.05 for 5 large frames in the sale. We have to calculate the original price of one. Okay, we are looking for just one large frame. Very good. We can just relate this, that when we're talking about the reduction by 18%, that means originally we have 100, but now since we are reducing it, that is minus 18. Okay, this is over 100 of the price, which we can call X, is equal to, now we're told that party pays this amount for 5 large frames, but the amount for one will now be that amount over 5. So we can have 166.05 divided by 5 large frames that we are talking about. So if we are to solve this, we can say this means 100 minus 18. What's 100 minus 18? That will be 82x over 100 is equal to 166.05 divided by 5, such that x in this case, if you cross multiply, will be 100 times 166.05 divided by 5 times 82. So we can find the value of that. We say 100 times 166.05 divided by, I want to put this whole denominator in a bracket so that is not mistakenly taken as the numerator. So I have 5 times 82. Okay. So this is 81 over 2, which is 40.5. So x is nothing but $40.5. And that will give us the solution to this question as appropriate. So finally, we can look at this question in which you are told that party advertises a large frame for a price of $57 or 48.20 euros. Now the exchange rate is $1 to 0.88 euros. We have to calculate the difference between these prices in dollars and cents correct to the nearest cent. So let's look at this. Since we are given that $1 originally is 0.88 euros, and then we have to find the differences between these prices in dollars and cents. That means our mandate should be to convert these euros to dollar and then look at the difference between that dollar equivalent and this 57 that we are given. So we can say S dollar is going to amount to 48.20 euros, such that from here we can have x to be cross multiplying like this, x and this, then 48 and this. It will be 48.20 multiplied by 1 divided by 0.88. So that will warrant that I can get x to be 48.20 divided by 0.88. So this is 54.72. This bar means it is 727272. So I can say 54.77. Okay. So this is 54.77. Then the difference that we are looking at will now be the difference between this 54.77 and this 57. So that will be $57 minus this 54.77, which is the amount when we converted. So we can look at 57 minus the answer we just got. So what's that? This is 2.2. Okay, 27 is being repeated, so I can say 2.23. $2.23. So that difference in price is $2.23. And with that, we've been able to solve this question as requested of us. In this question here, we're told that Japan runs a distance of 12 kilometers and then cycles a distance of 26 kilometers. His running speed is x kilometer per hour and the cycling speed is 10 kilometers per hour faster than his running speed. So we need to know that it is faster. Okay, so it takes a total time of 2 hours 48 minutes. That's the total time that he took for his journey. Now in the first question, I've been told that an expression for the time in hours that Japan takes to run the 12 kilometers is 12 over x, which is consistent. Okay, so we are to write an equation in terms of x for the total time it takes in hours. Let's note that the time in hours. So if you want to look at this to try and solve it, for me, I just love to represent all of this in pictures so that I can have a very good feel of what we are talking about. Here in this case, let's say we have this as the distance with which he is running, okay, and then we have this as the distance with which he is cycling, which is like 2 times the other distance. So here you can have him just running. So he's running like this, and here we have him is cycling. So let's take it that he's just having a cycle and cycling like that. So he's running at x kilometers per hour, and that distance was given as 12 kilometers. So from here to here, that is 12 kilometers. And then in the second case, we are told that his cycling speed is 10 kilometers per hour faster than his running speed. That means it will be x plus 10 kilometers per hour because it is 10 kilometers faster. So we needed to add 10 to the x with which he was running initially. Okay, and for that, the distance that he covered were given as 26 kilometers. Okay, so this is what we have. Ideally, we know that speed is distance over time, but we are told that the expression for the time in hours that Japan takes to run the 12 kilometers is 12 over x. So we can say t then is going to be, if you reverse this, it will be distance over the speed. Okay, so for this particular case, the time that it took for this phase of the journey in which it was running, this time will be, in the first case, the distance, which is 12, over the speed, which is x, that is for the phase in which he is running. In the second case, that distance will be again the distance, which is 26 kilometers, over the speed, and that speed we are given as x plus 10 kilometers per hour. Now we are told that this is amounting to 2 hours 48 minutes. That is the total time that it took. So we can say this is equal to 2 hours 48 minutes. But then look at this, we have 48 minutes. We should be able to convert that to hours. And this is what I want to say. I can say the total time is actually 2 hours 48 minutes. But we know that 60 minutes make 1 hour. So I can say 48 over 60. All right. And for this, I can cut 12 can go here 4 and 12 can go in 60. That is 5. So the total time that we have is actually 2 whole number 4 over 5. And if we are to express this as a whole fraction, this will be 2 times 5 is 10 plus 4. That is 14 over 5 as the total time. So the addition of the time it took in running, which is 12 over x, plus the time it took in cycling, which is 26 over x plus 10, is going to be nothing but 14 over 5. So what we are asked to get here will be 12 over x plus 26 over x plus 10 is equal to nothing but 14 over 5. So that is the equation in terms of x for the total time that it takes in hours. Okay. So here we have to show that this equation simplifies to 7x squared. Okay, so we are just to go ahead to simplify this. So if you look at this, you can see that 12, 26, and 14, 2 is common to all of them. So if we are to divide all through by 2, we are going to have 6 over x plus 13 over x plus 10 is equal to 7 over 5. So this is what we have. And if we are to get the LCM, we can say, therefore, this is giving us LCM on the left hand side will be the product of x and x plus 10. Then we have factoring out x from here, we have 6 into x plus 10. And then factoring out x plus 10 from here, we have plus 13x. This is going to give us 7 over 5. So we can do well to just cross multiply this so that we are going to have, okay, let's say we have, so that we are going to have 5 times the whole of this numerator. 5 times 6, that will be 30 into x plus 10, okay, plus 5 times 13x, 5 times 13, that's 65, plus 65x is equal to 7 into x times x is x squared, x times 10, that is 10x, okay. So we can just try and simplify this now. To say we want to open the bracket, we have 30x plus 300 plus 65x is equal to 7s squared plus 7 times 10s is 17x, okay. So if you have to rearrange and just take everything to one single side, I'm going to have 7s squared plus 70x. Here, 30x plus 65x is 95x. If I'm to subtract it from both sides, it will be minus 95x. Then this 300 will turn to minus 300 when we subtract from both sides. This will be equal to 0. So we can simplify this to say this is going to be nothing but 7s squared. 70x minus 95x is minus 25x. And then we have minus 300 is equal to 0. So this is what we are asked to show. And we can see that from here, we're able to arrive at the equation as requested. Here, we're asked to use the quadratic formula to solve the equation 7x squared minus 25x minus 300 is equal to 0. And we must show all our working. So we know that as a rule of thumb, for a quadratic equation, x, the solution is given as minus b plus or minus the square root of b squared minus 4ac all divided by 2a. In which, for this particular case, if you look at this, the general equation is as squared plus bs plus c is equal to 0. So if you compare this to this equation, we can see that a is amounting to 7, b is minus 25. Students, don't make that mistake. It's not 25, it's minus 25, and c is minus 300. So if we are to put in all those values, we can say x is equal to minus b will be minus 25. Be careful with your signs, okay? Plus or minus square root of b square will be minus 25 raised to the power 2, okay? Then minus 4, a is 7, and c is minus 300. Okay, so good and fine. We are dividing this with 2a, that is 2 multiplied by 7. Okay, so if you want to solve this, we are going to have it that this is the x here will be minus multiplied by minus will give us plus. So we have 25 plus or minus square root of 25 square, 25 raised to the power 2 is 625. Then this minus and this minus we multiply to be plus, and then we have 4 times 7 times 300, 8400, all divided by 14. Okay, so this we can simplify to be 25 plus or minus square root of 8400 plus 625 plus 625, 9025 over 14. So we are showing all of this because they asked us to show all of our working. So the square root of the answer we just got is 95. So this is 25 plus or minus 95 over 14. So if it is plus, that will be 25 plus 95, and that will be like 100 plus 20. So it's either we have 120 over 14, or we have minus 70 over 14. Okay, so we can just cut in this particular case. What can go here? Between 120 and 14, 2 can go. So x will either be 60 over 7, or x here, 70 over 14 will be minus 5. So you can see the consistency with which we work this out, and we just shied away from using our calculator. You can actually use the calculator to solve this. To say you are going to the equation mode, which is 5. So this is 5. And then we're having a quadratic equation, which is amounting to 3. So that is 3. What is a? That is 7. What is b? It is minus 25. Okay. And what is c? It is minus 300. So if we input that, we can solve for this. And you can see x1 is 60 over 7. We are on track. And then again, x2 is minus 5. We are on track. So you can always use that to confirm the solution to your question, and then you know that you're on the right track to excellence as you abide by all these principles as appropriate. So moving on, we are now being asked to calculate the number of minutes Tapan takes to run the 12 kilometers. Okay? If we recollect, we are given that time in which he is running to be 12 over x hours. Okay? But then this is to be expressed in minutes. So for us to convert hour to minute, this is what I would like to do. 12 over x hour means that we're having 1 hour, but then I want to convert this 1 hour to minutes. So to minutes, it will be that this is over 1, because 60 minutes makes 1 hour, such that I can now have this hour and this hour is knocking out, and this will be 12 multiplied by 60 over x minutes. Okay, so if I have this, all I just need to do is now that, look at these values. Can our minutes be negative? Our minutes cannot be negative. Our minutes will need to be positive. Okay, so we need to say that that time that it took to run is only going to be 12 multiplied by 60 divided by 60 over 7. So this is 12 times 60 over 1 multiplied by 7 over 60. So this 60 and this 60 will cut. 12 multiplied by 7, what is that going to give us? That is going to give us 84. So this is 84 minutes. Then we can put that as the answer here, that this is 84 minutes as the time that Dapan takes to run the 12 kilometers. In this question, we are told that the volume of a paper cone of radius 2.4 centimeter is 95.4 centimeter cube. So this particular cone, the radius here, the radius of the base is 2.4 centimeter, and the volume is 95.4 centimeter cube. Then the paper is cut along the slant height from O to AB. So along the slant height from O to AB, the paper is cut. Then the cone is open to form a sector OAB of a circle with its center at O. We are to find the sector angle x degrees. So if you want to see the transformation that happens when we cut this paper cone from O to AB, it is just as shown here. Okay, and what is happening is that this slant height is going to become the radius of the sector of the circle. So if I call this R, this is also R, as the slant height of the paper cone, which is also amounting to the radius of the sector of the circle. Okay, now if this is the height of the cone, we are not given that, but we are given the radius of the base circle of the cone, and that radius, the perimeter, is given as 2 pi r. I'm using small r for this particular 2.4 centimeter. Now that perimeter is going to translate into the length of the arc AB of the sector of the circle. So I can say that is also equal to x over 360 multiplied by 2 pi r, which is this radius of the sector of the circle. Okay, so having that, we are trying to find the sector angle x degrees, but for us to do that, we need to actually find r. Since we know that AB is equal to 2 pi r, this AB for the sector is also this AB for the circle, so we can equate those two if only we have the value of r. And for us to get the value of r, we can look at the paper cone to say, since we are given the value for the volume, then we have this particular radius of the base circle as 2.4. If we can get the horizontal height of that cone, then this we know is also r. We can use Pythagoras theorem to find r, so that we can use r in this particular case. So once we have that understanding, we can go ahead to say we want to try to solve this question to give us the solution that we need as appropriate. Okay, so first we can say that we have, from the information that we have the volume of the cone to be 1 over 3 pi r square h. Okay, so volume we have been given already 95.4 centimeter cube. R we have also been given as 2.4 centimeter. Then h is what we are looking for. From here you can say h is nothing but 3 multiplied by volume over pi r square. So if you want to evaluate that, you can say that h is going to be 3 multiplied by 95.4 divided by pi multiplied by r, which is 2.4 raised to power 2. So we can use our calculator to evaluate this now. Okay, so we are saying we are looking at 3 times 95.4 divided by 2.4 square. Okay, let me just put that in bracket so that I don't get confused. 2.4 square multiplied by pi, which is shift exponent here. Okay, so what's that going to give me? 15.82. So I can say my h from here is 15.82 centimeter. Okay, from that volume. Then having gotten that, I can see that from this triangle, h is the horizontal side here, 2.4 is here, then r happens to be the hypotenuse of this right angle triangle. So let me just get that out. So what we're having at least something like this, in which we have r here, we have 2.4 here, h, which we have gotten to be 15.82 is here, and by Pythagoras theorem we can say that r square is equal to h square, which is 15.82 raised to power 2 plus 2.4 raised to power 2. So that r square, so we can use our calculator for this. So say we have 15.82 raised to power 2 plus 2.4 raised to power 2. What's that going to give us? 256.0324. So that r itself will be the square root of that value that we got, 256.0324. And from our calculator again, we can say the square root of the answer, that's 16.0. Okay, we can just say this is 16. So this is approximately 16 centimeters. Okay, now since we have now gotten our r, we can now look at this sector to say the formula for this sector, x over 360 2 pi r that we just got, is also equal to 2 pi small r, that is the perimeter of the circle AB. So if we want to equate those two, we can say moving forward, we now have that perimeter of the base circle of the cone is equal to the length of arc of the sector of the circle that will be formed. Okay, and looking at this, I can see 2 pi is common to both. Okay, then r we know, small r we know, we are looking for x, and as easy as it gets, we can say that means that our x will be 360 multiplied by the small radius over the capital R that we just got. Okay, so since we have defined all these parameters, that means inherently what we're having is that x is nothing but 360 multiplied by 2.4 divided by 16. So this is what we need to put into our calculator: 360 times 2.4 divided by 16. Okay, so this is 54 degrees. Okay, it is the sector angle, so it is in degrees. So our final answer that we're asked to get is 54. And again, the explanation is that for the transformation of this particular cone to this sector, slant height of the cone is going to become the radius of the sector, and then the perimeter of the base circle of the cone is going to become the length of arc of the sector of the circle. If you just equate the parameters that we have, the volume of the cone, we're able to get h. We use Pythagoras theorem to get that slant height, which is r, that is also the radius of the sector of the circle, and then we use that to equate the perimeter of the circle AB to the length of arc AB of the sector, such that we got our final answer to be nothing but 54 degrees. All right. For this question, we're told that an empty fuel tank is filled using a cylindrical pipe with diameter 8 centimeters. Now, fuel flows along this pipe at the rate of 2 meters per second. Okay, so we should know that there is a difference in unit. Initially, we have diameter 8 centimeters, but now we're giving the flow rate at 2 meters per second. Okay, now it takes 24 minutes to fill the tank. We have to calculate the capacity of the tank, and then we have to give our answer in liters. A typical diagram of what this is going to look like is just as shown here, in which we have this particular cylindrical pipe that is filling the fuel tank with fuel as appropriate, and then the diameter is 8 centimeters and the fuel is flowing at a rate of 2 meters per second. First and foremost, we are giving this time in minutes, but we are giving the rate in meters per second, so we should take our minutes to seconds. So that time that we're looking at is 24 minutes multiplied by 60 seconds, and that will be, I think, 1440 seconds. Okay, you can confirm that with the calculator. But now, if we notice this, we are giving the flow rate of this fuel in this cylindrical pipe, and then if you want to take that as a volume, we need to say that the rate of flow in the pipe with respect to volume is going to be pi r square L, and I'm using that because it is meters per second that we have, so it's a flow rate. Now that r will be half of 8 centimeters, which will be 4. Okay, then that meters per second we should take to centimeter. So if we want to do that, that means what we're having here is pi multiplied by the radius, that will be 4 raised to the power 2, multiplied by the L. That L will now need to be 200 instead of 2 meters, will now to be 200 centimeters. Okay, so if you are to get this, I think this will be 4 raised to the power 2 is 16, so we have 16 times 200 pi, and that will be 3200 pi centimeter cube. Now we have it as per second because it's a flow rate. Now I'm using that flow rate because once we want to look at the time, then we can get the original capacity of the tank. So the volume of the tank is now going to give us the flow rate in the pipe multiplied by the time that we have. So such that what we're going to have is that, what's that flow rate that we got? 3200 pi centimeter cube per second. Then what's the time that we have? We have it as 1440 seconds, and I deliberately put in the seconds so that you see that this second and this second, they are going to cut out, and then our answer is going to be in centimeter cube. which we are even asked to convert to liters. Okay, so but first in centimeter cube we have 3200 pi, okay, multiplied by 1440. What is that going to give us? 144,76458.95. So we have 144,764, yes, I think 58.95. But this is in centimeter cube. For us to take it to liters, we need to divide by 1000, because it is 1000 that constitute, it is 1000 centimeters that constitute 1 liter. So once we are saying this is, and then it have to be 1 liter, okay, because it is 1000 centimeter cube that constitute 1 liter. So once we are doing that, we can say yes, what we got now divided by 1000. So this is 460, I want to get it straight. So 14476. But again, we're asked to always leave our answers correct to 3 significant figures. So that means 1, 2, 3. We need to consider the fourth number, 7. We'll round it up to 1 and add to the initial number. So we have 14500, 14500 liters as the capacity of this particular tank in liters. And with that, we are done with this question as appropriate. For this question here, we are tasked with the mandate to expand and simplify this expression, and let's just take it piecewise. First, these two, okay, so we are going to multiply x with each of these. So we have x multiplied by x is going to give us x squared. X multiplied by minus 2 is minus 2x. Then 1 multiplied by x is x. 1 multiplied by minus 2 is minus 2. Then we have open up the first set of 2 brackets. Then we can add the third one. That again, x squared multiplied by x, that will be x cubed. X squared multiplied by 3, that will be plus 3x squared. Minus 2x multiplied by x will be minus 2x squared. Minus 2x multiplied by 3 will be minus 6x. Then x multiplied by x, that is x squared. And x multiplied by 3, that will be 3x. Then finally, minus 2 multiplied by x is minus 2x. And minus 2 multiplied by 3 is minus 6. Such that if you are to take the like terms, we only have x to the power of 3. Okay, then 3x squared minus 2x squared, that will be x squared. Then plus x squared, this will be plus 2x squared. And then for x, we have minus 6 and plus 3, that is minus 3x. Okay, and then minus 2x, that will be minus 5x. And the only constant that we have here, that is minus 6. This is the barest minimum we can get to, so we can just write our answer as x raised to the power 3 plus 2x squared minus 5x minus 6 as the answer to this question. Then here, we have to make g the subject of the formula in this particular case. And first, we want to flatten out so that we can cross multiply. Here we have m into g minus c is equal to 2fg. Then we are making g the subject of the formula, so we should try and see how to isolate g out. This will be 2fg. Collecting like terms, we'll have mg minus 2fg is equal to mc. Then g is common here. G into m minus 2f is equal to mc. Then if we want to make g the subject of the formula, we can divide both sides by m minus 2f. So we can have g to be mc over m minus 2f. Okay, so that is how far we can go. We can just write that out as mc over m minus 2f as the answer when we make g the subject of the formula from this particular expression. Here we have to simplify this expression, and we can just see that from this, let's see what we can factor out from both the numerator and the denominator. In the first case, 4x squared and minus 16x, we can see that 4x is common. 4x is common. If you have taken 4x out of 4x squared, that will leave us with x. Then, if you have taken 4x out of 16x, that will leave us with minus 4. Then, here, x squared minus 16
this can be taken as the difference of two squares, in which a square minus b square is a minus b multiplied by a plus b. So if you can take this sum of two squares, we can apply it in this case to say this is actually s square minus 4 square. Okay, so if you want to expand that, we can say this will give us 4x into x minus 4, and then the difference of two square will be x minus 4 multiplied by x plus 4, and this can cut out such that our final expression can be 4x over x plus 4, which is going to be our final answer in this particular case. The probability that Shalini is late for school on any day is 1 over 6, and then we have to complete the tree diagram for Monday and Tuesday. So this is Monday, and this is Tuesday. Now, if the probability for lateness, if it is 1 over 6, the only other possibility is that he is not late. So the late prime will be 1 minus 1 over 6, and that is 5 over 6. So it's either it's late, in which the probability is 1 over 6, or he's not late, he arrived early, that will be 5 over 6. So this can help us to compute this particular tree diagram. So for him to be late, that will be 1 over 6. Not late, that will be 5 over 6. Then on Tuesday, for him to be late, still be 1 over 6. Not late is 5 over 6. Late is 1 over 6, and not late is 5 over 6. Okay? Then in this question, we have to find the probability that Shalini is late on Monday, but is not late on Tuesday. Okay? We need to be careful about this. Late on Monday will be 1 over 6. Okay? That is for Monday. And then not late on Tuesday, that will be 5 over 6. So the probability that is combining both of them, you can say that he is late on Monday but not late on Tuesday, will be the product of these two, and that will have to be 5 over 36, as the probability that Shalini is late on Monday but is not late on Tuesday. All right. For this question, we have it that the Venn diagram shows the number of students in a group of 50 students. Okay, so we can say that the universal set is 50 students, and who wear glasses, that is G, who wear trainers, that is T, and who have a mobile phone, that is M. So we have G, T, M. Now we have to use set notation to describe the region that contains only one student. Okay, if we look at the graph, where is the region that has only one student? We are seeing it is this. So that region that we are looking at is the one corresponding to only one student. Okay, and if we are to look at that, we are going to see that it is the complement of the union of G, T, and M. So if you have the union of G, T, and M, that is the one that is still in white here. The complement, the one outside of it, is the one shaded in blue. That is the region that has only one student. So if you want to append that in set notation, we are going to say this is going to be G union T union M. Those are the regions that are having these circles, but the complement of it is the one outside. So this is how to write it in set notation. Okay, for us to find the number of students that is being denoted with this T complement intersect G union M, T complement itself will be this region outside of T. You can see T is not being taken at all. Okay, that is T complement. Now G union M, the G union M will be something like this. This is G union M, the whole of G and the whole of M. Okay, that is the G union M. So we have to find the number of students that is actually intersecting in this particular two shaded regions that we have. And obviously, from what we have even shaded as a means of guide, we can see that is 0, 19, and 9. So if you want to do that, you can just say this is nothing but here it is 0 for G alone, plus 19 for this region here, and then plus 9 for M alone. That will be 19 plus 9, and that answer will be 28. So the number of students in that category is 28. Okay. Now, one student is picked at random from the 50 students. We have to find the probability that this student wears trainers but does not wear glasses. Okay, we have
trainers but not glasses. We need to look at our graph again. We should be considering somewhere here. Trainers, where is the region for trainers? This is the region for trainers, okay? But then we are now being told that not glasses, okay? Then we need to exclude glasses out of it. So glasses is out. We have trainers only, okay? So the student may be wearing trainers and also having a mobile phone, but is having trainers but not wearing glasses. So you can see that we have excluded the glasses out of it. So that number, as you can see here, is corresponding to 14 and 3. But since we are just picking these students out of the total number of students, which is 50, the probability will be 3 plus 14 over 50. So that is what we are going to be doing to solve this question. That this is nothing but 3 plus 14 over 50, and 3 plus 14 over 50 will give us 17 over 50, as a probability that this student that was picked wears trainers but does not wear glasses. So we have this as 17 over 50. Okay. Here we have that 2 students are picked at random from those wearing trainers. Originally they are wearing trainers, so they are being picked from those wearing trainers. We have to find the probability that both students have mobile phones. So if you look at our graph, our Venn diagram again, we are going to see that, okay, where are those that are having trainers? If we want to identify that, we have this as trainers. Those are trainers. Now we are being told that we have to find the probability that both of them, they have mobile phones. For that particular case, the total possible outcome would be the sum of all of them, because this is constituting all that have mobile phones, all that have trainers. So that would be 2 plus 2 plus 3 plus 14. This would be 14 plus 3, 17, 18, 19, 20, 21. Okay. So if we are looking at those that have mobile phones, that would be 2 plus 14, which is 16 over 21 for the first case. And then in the second case, we need to duplicate that number. So if we want to solve it, we are saying that from that particular data that we have, that probability that we are looking for will have to be 16 over 21 for the first student. We are saying that we are picking them at random. After picking the first student, the possible outcome remaining will be 15 over 20. We have duplicated the total number that have mobile phones from 16 to 15. I have duplicated the total number that are wearing trainers from 21 to 20. So this is going to be the probability that we are looking for. And we can cut 4 here 4, 4 here 5, 5 here 3, 5 here 1, 3 here 1, and 3 in 21 is 7. So this will be 4 times 1, that is 4, 7 times 1, that is 7. So 4 over 7 is going to be the probability that both students who are picked at random from those wearing trainers have mobile phones. And with that, we've answered this question on probability and will be good and fine. Here we are to solve the equation tan x is equal to 11.43 for the value of x ranging from 0 degrees to 360 degrees. Now, before we first go ahead to try and solve this, we should know that we have angles that we can have as either A, C, T, or S, denoting the regions that are positive. Here in the first quadrant, all is positive. In the second quadrant, cosine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, sine is positive. So that will be a guide for us, and we know that we are moving in this direction anytime we're actually moving on those quadrants. So let's try and see how we can solve this question that we have tan x to be 11.43, and in this case x will be arctan of 11.43. So we can put that into our calculator that we are looking for arctan 11.43. So what's that going to give us? 84.999. Okay, and we are looking at 3 significant figures. Okay, this will be 85. So you can say this is approximately 85 degrees. But now we need to consider our quadrant. In this particular case, we are working with tan and the value is positive. Where are the two regions where tan is positive? It is here where all is positive, and here that we are looking at. So we can say we are looking at something like this, in which we either have our tangent, our theta to be here. Okay, so this can be our answer, or it can also be here. Here can also be the region of interest, in which that angle is denoted there, and that second angle if you want to look at it, this will have to be from the starting point up to this horizontal line, that is 180. So here, if you want to sum everything, to be 180 plus theta. So if you are looking at our solution to the question, we can say that it's either x is equal to 85 degrees, or we have x to be 180 plus 85 degrees. Okay, so if you are to solve for that, we can say that our x will be 85 degrees, or for this second case, we can say our x is 180 plus 85, that would be 265 degrees. So we can put that as our answer, that x is 85 degrees or x is 265 degrees. So we can move on to this, our next question. Okay. In this question, we're asked to sketch the curve y is equal to x raised to power 3 minus 4x, and we have been given the plane to work with. And for us to do this, that means that we need to look for the solution to this particular curve. And we'll normally obtain that solution when the value of y is 0. That's why we actually compute it on the x-axis. Okay, so we can say when y is equal to 0, we know that that will give us x raised to power 3 minus 4x is equal to 0. And then if you factor out x, this will be x into here, x squared will be remaining out of x3. Then minus 4 will be remaining out of the other one. But we know that minus 4 is actually 2 raised to power 2. So we have this to be 0. So that what we are looking at is nothing but here, difference of 2 squares, which is x minus 2 multiplied by x plus 2. So that we have it as x into x minus 2 into x plus 2 is equal to 0. And then the solution to this will mean that is either I have x to be equal to 0, or x is equal to 2, or x is equal to minus 2. That's the solution for all of this. X is either 0, or x minus 2 is 0, so that x will be 2, or x plus 2 is 0, so that x will be minus 2. So these are the solution points, and I can say we are looking at x is 0 here, then x is here, x is minus 2, and then here, let's say x is plus 2. So those are the values for x. But we need to find the corresponding values for y. And for us to get that, we need to say that at the turning point, we have it that the y dx is equal to 0. And if you have the function that we are given that y is equal to x cubed minus 4x, such that the differentiation of y with respect to x, in this case, will be 3x squared by differentiating x raised to power 3 minus 4 by differentiating minus 4x. Okay, and that we are going to equate to 0. This is the differential value of y with respect to x. And then if you have to solve for this, let me pull my... So we have to solve for x here. We can see that means we have 3x squared is equal to 4, and then x squared itself will be 4 over 3, such that x will be plus or minus the square root of 4 over 3. And if you have to use our calculator on this, we have square root of 4 at the numerator, 3 as the denominator. What is this going to give us? 1.1547. This is 1.1547 as the value of x at the turning point. So that means we have, let's say we have 1 here, we have 1 here. Somewhere just after that, that's where we're going to have those turning points. But then, what are the corresponding values for y for those turning points? So you can say when x is, let's take the positive value, is 1.1547, we're going to find the value of y to be in the original equation. What is y? Y is x raised to power 3 minus 4x. Okay, so using the value of x, we can just say that's going to be, I will just compute this on the calculator, that I'm having s raised to power 3 minus 4x, and I want to calculate this for values of x to be 1.1547, 1.1547. What's that going to give me? This is minus 3.079, or let me say minus 3.08. So that is minus 3.08, so that I have that point as 1.1547, minus 3.08 as the value of y for x when x is 1.1547. And then when x is minus 1.1547, the value of y, also in this equation, we can get that to say we want to calculate this, but now we want to put minus 1.1547 as the value of x. So this is going to be, okay, 3.07 now, 3.08. Y is 3.08. So I have another point, 1.1547, 3.08 as the other turning point in this case. So looking at the graph, I can just say that I want to take 3.08. Let me just say here, this will be 3.08. Then just here, minus 3.08 as those values. So if I'm to extrapolate those values that I'm seeing, I'm going to say that in the first case, we have x is 0, that is here, x is 2, that is here, x is minus 2, that is here, and for those horizontal values of x, y is 0. But then to get the turning point, we are saying that for those turning points, when x is 1.1547, y is minus 3.08. So we have this and this point. Okay. And then when x is minus 1.1547, y is 3.08. We have here and this point. And it is just a sketch. So our mandate will be to join all of these together to get our appropriate curve in this particular case. I'm going to just be doing that right about now. So if we compute that appropriately, we are going to have our curve joining all of those points like this. And in this manner, we have been able to sketch the graph for the curve y is equal to s raised to power 3 minus 4s as requested of us, and our full mark will be assured as appropriate. Okay, here again on curves, we are given that a curve has equation y is s raised to power 3 plus ax plus b. Now the stationary point of the curve have these coordinates 2, k and minus 2, 10 minus k. We are to work out the value of a, the value of b, and the value of k. Okay, very good and very interesting. We just need to know that for what we are given that y is equal to x raised to power 3 plus ax plus b, we should know that the differential value of that with respect to x at the turning point is equal to 0 at turning point. Okay, these turning points are the stationary points. So if we get that, we can now say that means let's differentiate this. That dy dx that we are talking about is actually 3s squared. Of course, if you differentiate ax, that will be a. Then that is what we are given to be equal to 0. But looking at what we have it that, but we have these 2 points, 2, k and minus 2, 10 minus k as those stationary points. So first, let's say when x is equal to 2, here in this first case, then we are going to see that 3 multiplied by 2 raised to power 2, because we are putting that as the value for x, okay, plus a, that is equal to 0, such that here 2 raised to power 2 is 4, 4 times 3, that is 12. A is going to give us nothing but minus 12, okay, and then we have it that y is equal to k, because this is x is 2, k is still k, that's the value for y, then a is minus 12, we have gotten that. Then in the second case, when we have x to be minus 2, what are we going to have at the turning point using this differential equation? We are going to have 3 multiplied by minus 2 raised to power 2 plus a is equal to 0, and then again we are still saying that a here, it will still be the same answer. It will be minus 12, because minus 2 raised to power 2 is 4, 4 times 3 is 12. When we subtract 12 from both sides, here will remain a, this will be minus 12. But here the interesting is that y will now be 10 minus k, just as we are given originally. Okay, so if you want to now substitute these values back in the original equation, we can say that at x is equal to 2, if you want to put the value for y, of course, at x is 2, this is x is 2. What is the value for y? In the original equation here is k, so we can say k is equal to, instead of x now, we have 2 raised to power 3 plus ax. What is the value for a? We got a to be minus 12. Okay, multiply by x. What's the value for x? That is 2. Then plus b, which we don't know yet. Okay, let's say we collect like terms. So we have k minus b is equal to 2 raised to power 3 is 8. So we have it as 8. Then minus 12 times 2 is 24. So here we have it that k minus b is equal to 8 minus 24 is minus 16. All right, let's still keep that equation. And then in the second case, at the point when x is equal to minus 2, if you want to use in this original equation, we are going to say that what is the value for y? We gave our x is minus 2, but y is 10 minus k. So we have 10 minus k is equal to the value of x minus 2 raised to power 3 plus a. You can see we also got a to be minus 12. That's quite consistent. Okay, multiply by x now. That value of x is minus 2, then plus b, which we are looking for. Again, if you say we want to try and collect like terms, here minus k and b. Okay, let me just move k to the other side so that I have k plus b will now be, here I have 10, then this is minus 2 raised to power 3 is minus 8. Then if I take it to the other side, it will be plus 8. Then minus 12 multiplied by minus 2 is plus 24. If I take it to the other side, it will become minus 24. This is just some simple simplification so that we have k plus b is equal to 10 plus 8 is 18. 18 minus 24, this is minus 6. And you can see we have these two sets of equation 1 here, and we have this equation 2 here, that we can attempt to solve to try and find the value of k and b. Already we have a to be minus 12, but now we need to find k and b. And looking at what we have as k minus b is equal to minus 16 and k plus b is equal to minus 6. If I'm looking at these two, I can say I want to add the two of them together. K plus k will be 2k, minus b plus b will be 0. This is equal to minus 16 plus minus 6. That's going to be minus 22. And then from here I can say k is minus 22 over 2, which is minus 11. So having gotten the value of k to be minus 11, from this second equation, I can say k plus b is equal to minus 6, such that b will be minus 6 minus k. So that b will be minus 6 minus 11. So this will be minus 6 plus 11, and that will be 5. Such that here, what we are requested to find, the value of a, we got to be minus 12. A is minus 12, all right? The value of b we got to be 5. B is 5. The value of k, we got to be minus 11. And we use the understanding that even though we have all this information that we are given, we know that consistently at the turning point, at the stationary point, the value of the differential value of that function is going to be 0. And then we just substitute in those values and then go back to use the value for x and then y to expand so that we have our equations, which we eventually solve to give us a to be minus 12, b to be 5, and k to be minus 11. And with that, we have come to the end of this beautiful journey on solving the Cambridge IGCSE Mathematics 058042 for the year 2022. And I hope you have found this useful. Don't forget to subscribe to the channel, and don't forget to also share with your friends, share with your loved ones, and we believe that would have helped you on the path to excellence. It's been a wonderful journey. Thank you for staying tuned up to this moment. It's DaveTuts Academy, and until next time, God bless you.